Hello friends, today we will study numerical based on shear force and bending moment diagram. First example, draw Sfd and Bmd as shown in figure below. This figure is the simply supported beam with point load and UDL. This is the support reaction at A means RA and support reactions at B point means RB. The 2 point loads, first point load is 3 kN and second point load is 5 kN. This is the UDL. UDL of the span is 3 meter with load 4 kN per meter. How to convert UDL to equivalent point load? Means force into distance. Then 4 into 3, 12 kN, and which is located at midpoint of the span and half of distance 1.5 meter and 1.5 meter. So how to solve this numerical? What is the first step? First step is to find out support reactions means RA and RB. So first step is the find out support reactions RA and RB. So by applying equilibrium conditions, summation fx, first condition is the summation fx is equal to 0. Means summation fx means algebraic sum of all x component is equal to 0. There is no horizontal force, therefore summation fx is equal to 0. Then second condition is the summation fy is equal to 0. Means algebraic sum of all y components is equal to 0. So this diagram summation fy is equal to 0, algebraic sum of all y component is equal to 0, upward force taken as positive direction and downward force taken as negative direction. So first upward force RA plus upward force downward force 3 kN means minus 3 kN. Then next for equivalent point load means 12 kN. This is the downward force minus 12. Then downward force minus 5. Then plus RB upward force is equal to 0. Then RA plus RB is equal to 12 plus 3, 15 plus 5, 20 kN. This is the first equation. Then third condition is the summation moment at point A is equal to 0. Means algebraic sum of all moments at point A is equal to 0. First of all, we have to know what is meant by the moment. Moment is the force into perpendicular distance. At point A, what is the first force? C. First force C, second force means UDL, third force 5 kN and last force RB. So first of all decide the rotations for these forces. First force C 3 kN, this is the downward force. Decide the rotations at point A. This is the clockwise direction means plus. This is the clockwise moment means plus. Then third force is the clockwise direction plus. And last force is the anti-clockwise direction means negative. Then first force which are rotating clockwise, second force clockwise, third force clockwise, and last force is the anti-clockwise. Clockwise moment taken as positive direction, anti-clockwise moment taken as negative direction. So moment is the force into perpendicular distance. So first force is the 3 kN 3 into perpendicular distance C to A means 1 meter. Then second force is the clockwise plus 12 into perpendicular distance 1, 2 and 1.5. 1 plus 1 plus 1.5 means 3.5. Then third force is the 5 kilonewton. This is also clockwise means plus 5 into perpendicular distance 1 plus 1 plus 3 plus 1 means 6. Then next last force is the RB. RB which are rotating at anti-clockwise direction means minus RB into total span of the distance is 7 meter is equal to 0. Then calculate the value of RB. Then we get RB is equal to 10.71 kilonewton. This is the positive force. Then this sign convention is positive direction. Then put the value of RB. Put the value of RB in equation 1. Then we get RA. RA is equal to 20 minus 10.71. Then RA is equal to 9.29 kilonewton. Then step second, shear force calculation. First of all, we have to know what is meant by the shear force. Shear force is algebraic sum of all the forces which are acts in left and right of the section is known as shear force. Then shear force at point A. Shear force at point A left is equal to 0. A left, there is no force for left of point A is equal to 0. Then shear force at A right, the force whose acts on its own point. Upward force taken as positive direction means RA is equal to 9.29 kilonewton. Then shear force at C left. Then shear force at C left is equal to C. There is no force in between point A to C. Therefore, C left is equal to, as it is previous value, 9.29 kilonewton. Then shear force at C right. C right 9.29 minus 3. This is the downward force. 9.29 minus 3 is equal to 6.29 kilonewton. Then shear force at E left is equal to E left. There is no force in between C to E. Therefore, as it is previous value, E left 6.29 kilonewton. 6.29 kilonewton. Then SF at E right is equal to the force whose acts on its own point means E right. Then shear force at E point R right is equal to 6.29 kilonewton. So there is no force acts on its own point means E point. Therefore, as it is previous value, E right is equal to 6.29 kilonewton. Then shear force at F left is equal to, at F point, F left, there is only one force means 12 kilonewton force. So F left F left 6.29 minus 12, 6.29 as it is previous value minus 12 is equal to minus 5.71. Then SF at F right there is no force at its own point, so minus 5.71 as it is minus 5.71 kilonewton. SF at D left there is no force in between point F to D, so D left as it is previous value minus 5.71 kilonewton. Then SF at D right, SF at D right minus 5.71 minus downward force minus 5. SF at D left is equal to minus 5.71 kilonewton. D left means there is no force in between point F and D, therefore as it is previous value. Then SF at D right is equal to minus 5.71 minus 5 is equal to minus 10.71. Minus 5.71 minus 5, D force minus 5, downward force is the minus 5 is equal to minus 10.71. SF at B left is equal to minus 10.71 kilonewton. B left means there is no force in between D to B, therefore as it is previous value B left minus 10.71 kilonewton. SF at B right is equal to B right minus 10.71 plus what is the value of RB plus 10.71 is equal to 0. Draw SFD diagram. So what is the first value? Shear force at A left is equal to 0, 0 value. Then second, A right 9.21, that is plus. Then plus value which are located above the baseline and negative values which are located in below the baseline. So A right is equal to 9.29 kilonewton, 9.29 kilonewton. Then C left 9.2 kilonewton, 29 kilonewton, 9.29 kilonewton. Then C right 6.29 kilonewton, 6.29 kilonewton. Then E left 6.29 kilonewton and E right also 6.29 kilonewton. E left and right are the same value, 6.29 kilonewton. Then next, shear force at F left minus 5.71 kilonewton, that is negative value which are located in below the baseline. So F left and right are the same value, minus 5.71 minus 5.71. Then D left minus 5.71 minus 5.71. Then D right minus 10.71 minus 10.71. B left minus 10.71, B left minus 10.71, B right minus 10.71 plus 10.71 is equal to 0, means B right is equal to 0. So this is the shear force diagram. SF changes positive to negative, which is known as, this is the zero shear force. This is the similar triangle. Above values all positive, then which is located at positive sign. Below values negative, then which is located at negative direction. Then third step is the bending moment calculation. Bending moment. First of all, what is meant by moment? Moment is the force into perpendicular direction. So bending moment at A is equal to 0. Bending moment at point A is equal to 0. For simply supported beam, the bending moment of end points is equal to 0. Okay, so bending moment at C. Bending moment at point C. First of all, how many forces which are acts in left section at point C? Only one force. So this force decide the rotations. This is the clockwise moment taken as positive direction. So plus 9.29 RA. What is the value of RA? 9.29 into perpendicular direction, perpendicular distance 1 meter. 1 is equal to 9.29 kilonewton meter. The next, bending moment at point E. How many forces acts in left section from point E? 1, 2. First force is the clockwise and second force is the anti-clockwise. So for clockwise moment taken as positive and anti-clockwise negative. So for first force 9.29 into perpendicular distance A to E 2 meter. 9.29 into 2 minus second force is the 3. This is anti-clockwise minus 3 into perpendicular distance 1 is equal to 15.58 kilonewton meter. Then next point, bending moment at F. How many forces which are acts in left section from point F? First, second, third. First force is rotating at clockwise, then second anti-clockwise, third anti-clockwise. So first force is the 9.29 into perpendicular distance 5 A to F, 1 plus 1 plus 3, 5 distance, then minus second force 3 into perpendicular distance 4. Then third force is the 12 equivalent point load minus 12 into 1.5. This is equal to 16.45 kilonewton meter. The bending moment at point D. At point D, how many forces acts in left section? First, second, third. Only 3 forces. So first force is clockwise and other 2 forces are anti-clockwise. Then 9.29 into 6, 1 plus 1 plus 3 plus 1 into 6. Then minus second force is anti-clockwise minus 3 into perpendicular distance 5 minus 12 into perpendicular distance 1.5 plus 1 means 2.5 is equal to 10.74 kilonewton meter. Then bending moment at point B is equal to how many forces acts in left section? 1, 2, 3, 4. 4 forces are there. First force is the 9.29 into total span of the distance is 7 meter minus anti-clockwise minus 3 into perpendicular distance 6 minus equivalent point load 12 into 1.5 plus 1 means 3.5 is it then minus 5 into perpendicular distance 1 is equal to 0. Then bending moment, we have to calculate bending moment at point G. So similar triangle law, 6.29, 5.71. This figure shows that 6.29 upper value, lower value 5.71. And left forces, first is the RA, RA force A point, then C point 3 kilonewton force, then E point, and UDL is the 4 kilonewton per meter, and UDL is the triangle. Then by applying the similar triangle law, upper value is the 6.29 and lower value is the 5.71. Suppose point E to G is the distance x and total span of the UDL E to F is the 3 meter. E to F is the 3 meter. So by applying similar triangle law, so 6.29 divided by x is equal to 5.71 divided by 3 minus x. Then cross multiplication, we have to calculate x is equal to 1.57 meter. Then bending moment at point G is equal to how many forces acts in left section from point G? 1, 2, 3. Okay, so first force is the RA, means RA is equal to 9.29. So 9.29 into perpendicular distance 1 plus 1 plus x means 2 plus x. Then second force is the anti-clockwise direction. This force which are rotating anti-clockwise, then minus 3 into perpendicular distance 1 plus x, minus 3 into 1 plus x. Then third force is the 4 kilonewton per meter. This is the UDL. So first of all we have to convert UDL to equivalent point load. So 4 into x means 4x is the equivalent point load. 4x is the equivalent point load into perpendicular distance. 4 into x means 4x is the equivalent point load and which is located at midpoint of the span means 4x, and half distance means into x by 2. This is the perpendicular distance from this point to this point, this point to this point. Okay, so put the value of x 9.29 into 2 plus x. What is the value of x? 1.57. 2 plus 1.57 minus 3 into 1 plus 1.57 minus 4 into 1.57 into 1.57 divided by 2. Then we get bending moment at G is equal to 20.55 kilonewton meter. This is the bending moment at point G. So this diagram shows that bending moment at point G is equal to 20.55 kilonewton meter. So bending moment, how to draw the bending moment diagram. First point, bending moment at A point is equal to 0. At A point is equal to 0. Then bending moment at C is equal to 9.29 kilonewton meter. C is equal to 9.29 kilonewton meter. Then bending moment at E is equal to 15.58 kilonewton meter. At point E is equal to 15.58 kilonewton meter. Then this diagram E to F is the UDL. So point E to F is the UDL. Then point bending moment at F is equal to 16.45. Then bending moment at point G is the 20.55 kilonewton meter. Then bending moment at D is equal to 10.74. Bending moment at point D is equal to 10.74 kilonewton meter. and bending moment at point B is equal to 0. Bending moment at point B is equal to 0. So it is clear that shear force, when the shear force is maximum, then bending moment is 0. Shear force is maximum, bending moment is 0. When shear force is 0, then bending moment is maximum. For a shear force diagram, suppose we have to draw the horizontal line, then in bending moment diagram is the inclined straight line. Okay, in shear force diagram, incline, we have to show the inclined line, straight line. Then for bending moment diagram is the parabolic curve. This is the inclined straight line, this is the inclined straight line, and this is the parabolic curve. In shear force diagram, horizontal line. Bending moment diagram, inclined line. In shear force diagram, inclined line, and bending moment diagram, parabolic curve. When shear force is 0, then bending moment is maximum. When shear force is maximum, then bending moment is 0. Thank you.